Here we go, lesson 5.3. Make sure you have 5.3 open in your notes. Estimate products of multi-digit factors. So the goal by the end is to be able to explain how to estimate products of multi-digit factors and estimate products of multi-digit factors to determine if calculations are reasonable and to make predictions. So that's sort of why we want to estimate. So being able to do it and understanding like why in the world would I need to do this. And remember, products is just the answer when we multiply. Factors are just the numbers we multiply together. So these ones will have multi-digits or more than one digit. So the problem, on Saturday, 432 people go to the theater. About how much money does the theater collect on Saturday? Well, if you notice, the price is $13 for each ticket. So if we know we have $13 a ticket and we have 432 tickets, sorry, I was just trying to close this and my thing is in the way. There we go. So how much money will that be? Well, 432 groups of 13, we could multiply to figure it out. But notice it says about how much money. So that means we just are trying to find an estimate. Remember, if it says about, we can just estimate, not find an exact. So what strategies could we use to estimate a product? Well, one of the strategies is to use something called compatible numbers. So go ahead and write that in your notes. One way to estimate is to use compatible numbers. Now, compatible numbers are numbers that go nicely together. So like 7 times 8 is 56. So 56 divided by 8 is like compatible. 56 and 8 go together nicely because I know that 7 times 8 is 56. So for 432 and 13, some compatible numbers that I could choose would be 415. So I could say that one is close to 400, that one is close to 15, because I know that 4 times 15 is 60. It's like on a clock. It's easier to multiply by 15s than 13s, because 15 is a number that we come across more often. That's sort of what it means by compatible numbers. It's not an official rounding strategy. It's just picking numbers that are close, that you know sort of are more familiar with. So then if we do 400 times 15, well, we can do 4, come on, pen. My pen does not like to work. 4 times 15 is 60, and then 2 zeros. I put my 2 more zeros on, so it is 6,000 is my answer. You may want to make a note on your sheet how we rounded 432 to 400, not rounded. We changed it to 400. 13 we changed to 15, again, because they go nicely together. Now, you might not know like what goes nicely together, so this next strategy might be something that you use more often. This is what I would say I'm more familiar with. Here they're just going over, look, 400 times 15, 4 times 100 times 15. I just did 4 times 15, and then did times 100 to get those 2 zeros. So the other way to do it is just to use rounding, okay? So just round the numbers either to the nearest 10. You could do 1 to the 10, 1 to the 100. Round them to something they're close to, and then multiply. That is what I would say. I would recommend if you're not sure, like, I don't know what are compatible, just round them. So in this case, if I round them each to the nearest 10, it's good practice in our rounding. Well, 3 is in the tens place. 2 tells me to stay the same, so I get 430. 13, 1 is in the tens place. 3 tells me to stay the same, so it's 10. So I'm doing 430 times 10. So I can do 43 times 1 is 43, 2 zeros, 2 zeros. So 4,300. Now do note that when we multiply or when we round and estimate with multiplying, our answers are going to be farther away generally than when we're adding. So you might say, one of my estimates was 6,000 and the other one was 4,300. Those are really far apart. And yes, they are, but it's at least, they're both in the like single digit thousands versus like getting 24,000 and 4,000. Then you're like, whoa, we're talking like just much more different than if they're just a couple thousand apart. But just something to keep in mind that they might be farther apart, and that's okay. So yes, 430 and 10, like I showed, it's 4,300. So is it reasonable? Because that's, if we calculate it out and we get 5,616, is that reasonable based on our estimates? Well, yes. It's about 1,000 away from one. It's about 1,000 away from the other. Really, it's only about 400 away from one and a little farther from the other. So yes, that shows me that it's a reasonable answer, that I probably multiplied correctly. So again, that's why we might use rounding. So it's like, oh, okay, check and see if my answer that I got makes sense. All right, so we're going to do a practice here, 879 times 36. So I want to show you that there's sort of two different options for what you round to. So if I have 879, okay, I could round that one to a couple of different things. I could either round it to 880, or I could round it to 900. Okay, depending on if I round to the tens place or the hundreds place. Either one is fine. It's just going to affect how close my answer is to the actual one. And we're doing times 36. This one, there's not really options. I'm going to round to the nearest 10, and I'm going to get 40. Now, the reason I say maybe choose, because if I round to the nearest 10, 880 times 40, I can't do that in my head because I don't know 88 times 4 in my head. I could write it down and get an estimate, but for me, the point of estimating is to kind of be able to like do it in my head and do it a little quicker. So I would choose to do 900 times 40, and then I would get 9 times 4 is 36. 1 0, 2 0, 3 0. Put my 3 zeros on. So 36,000. Okay? If I had done 880 times 40, I would just have to do 88 times 4. And I'd say, okay, that's 32. Okay, that's 32 plus that's 35. So 352. Then again, I just have to put on 2 zeros this time. But notice, either way, 36,000, 35,200, they're both pretty close together, okay? I know my answer is probably going to be a little closer to this one because I didn't round as far, but this is still a fine estimate that I could use. If you're struggling with either the rounding part or like, how do you know how many zeros to add? How are you getting them? Make sure you ask. Okay, because we've done a lot of rounding, so I'm not going to spend a lot of time on that, but I can if you need it. Here we go. It's loading. It's just a little slow today. So go ahead, estimate the product 643 times 18. Again, don't find the actual, just estimate. All right. Now, obviously, you have to choose from one of the options I gave you. There's other ways to round, as we just said. But I just went with rounding to sort of that first place. So round that to the hundreds place, so I get 600. Round that to the tens place, I get 20. 6 times 2 is 12. 1, 2, 3 zeros. 1, 2, 3 zeros. So I get 12,000. Now, just for sake of showing to say, okay, is that reasonable? I'm just going to do it on here to get the actual answer. So 11,574. If I had worked that out and I'd said, okay, is that a good, does it seem reasonable? Well, 12,000, pretty close to it, so it makes me feel more confident in my answer. Versus if I accidentally multiplied wrong and I got like 800, I might say, well, 800 is really far away from 10,000, so I probably made a mistake in my multiplying. So it's just another helpful way to check. All right, estimate the product, 325 times 62. All right, hope you got it. If you chose different compatible numbers or something and you got a different answer, you could still be right. Just keep in mind, you can always call me over if you're wondering, like, did I do a good job estimating, even if you got a different answer? So I would round 325 to 300. 62, I'd round to 60. Multiply 3 times 6 is 18. 1, 2, 3 zeros. 1, 2, 3 zeros. All right, let's just do one more. All right, 438 times 27. All right, hope you got it. 438, I would round to 400. 27, I would round to 30. Again, if you're like, how do I know that? Then ask for help, okay? Because that 3 tells my 4 to stay the same. The 7 tells my 2 to go up to a 3. 4 times 3 is 12. 1, 2, 3 zeros. 1, 2, 3 zeros. Just multiplying this number times this number and adding on that many zeros. All right, let me know if you need help, and good luck.